Hello, today we are going to see one of the algorithm design technique that is called divide and conquer. The content of the today's lecture will introduce what are divide and conquer techniques. Then we will see some of the examples of divide and conquer technique. Then we will learn how to design an algorithm using this technique and how to write the recurrence relations. And at the end, we will discuss the advantages and disadvantages of this technique. So, as the name suggests, divide and conquer. It means that if you have a very big problem, what you will divide that problem into smaller parts, and you will keep on dividing that problem till you reach a point where you get a obvious solution. Okay, suppose you have a very large problem. For example, let's see binary search. In binary search, the array is sorted. What you do, you always calculate the mid element. If the element you want to find is greater than mid, then you look in the upper part of the array. That is the right hand side of the part of the array. So the size of the problem is reduced by half in that case. So that algorithm works on divide and conquer technique. Okay. So how it works. So let's see what are the steps in divide and conquer. The first step is you divide the problem. Suppose there is a very big problem, you keep on dividing the problem into sub problems. Then by calling recursive function, you try to solve those problems. You will divide the problem till you reach a stage where you get the obvious solution. After getting the obvious solution, you'll start combining those solutions and reach the solution to the higher problem. This is a diagram which represents the divide and conquer technique. See, you have a very big problem. This problem consists of A to I problems. This is a very big problem from A to I. In the first step, you are dividing this problem into these sub problems. Okay. So you have divided all the problems into these 10 parts. After then, you are applying some techniques to solve these problems. So you have solved the solution of this small a is now capital A. The solution to small b is capital B. Similarly, the solution to small I is capital I. Okay. Then at the end, after getting the obvious solutions, you will start merging the solutions or combining the solutions. So this A, B, C, D, E to I, they are merged and you reach the final solution. So this is how your divide and conquer technique is going to work. Now let's see how to design an algorithm for this. Suppose you have a problem, divide and conquer, and you are given an array A. The starting index of the array is I and the last index of the array is j. Now after dividing, you have reached a smaller problem which is of the form of array A, and this I and j, they bring you the obvious solution. Then you will return that solution. Else you will keep on dividing these problems. Okay. Suppose that here I am dividing the problem from mid. So one part of this problem becomes from A in the array A from index I, from the starting index till the mid part. And the second part becomes in the array A from mid plus 1, the next half part till the end of the array. After getting the solutions, we will combine the solutions. The first half was stored in this variable B. The second half was stored in this variable C. And we are combining these variables B and C and storing them in a variable D. At the end, we are returning the solution of D. So this is how you design a divide and conquer algorithm. Now how to design the recurrence relation of a divide and conquer algorithm. If the solution is obvious, you will reach there by taking a single step. Then it will take order of one time. Otherwise, you will divide the problem into half. So a problem of size n is going to take time t of n by 2 because you are dividing the problem into half and you are dividing it in 2 half. That's why this 2 has come. And at the end you will combine. For that, it is a function f2 of n and f1 of n is the function, which is the time taken by the function to divide. Some of the famous examples of divide and conquer technique are binary search, as I have discussed earlier. Then comes merge sort. We will see later in this lecture how merge sort works. Quick sort, we will see this in another lecture. Stresses matrix multiplication. This is a part of your unit 3. So we will discuss it there. What are the advantages of using this technique? See, solving concept, if you have a very big problem, you keep on dividing the problems. The name has been derived from, from history, the divide and rule. The Britishers used to divide the area, and by dividing the area, when they see that they can conquer that area, then they will conquer, and ultimately they conquered the whole. That's how this divide and conquer technique is going to work. Your larger problem will be divided into many smaller problems, many sub problems. When you get the solution of those sub problems, you'll start merging those solutions and you will reach the solution of the final problem. So advantage is you can execute these sub problems on parallel machines or on distributed machines with multiprocessors. And the only disadvantage is the recurrence as compared to iteration process is slow. So now let's see how merge sort works. Today we are going to see one of the sorting technique, that is merge sort. Okay. Suppose we have an array A. So what we will do is we will divide this array into two equal parts. Suppose the first part is this left array and the second part is this right array. Okay. Then we will try to sort this left array and right array independently. We will follow a recursive process to sort this left part and right part. Suppose after sorting, this L becomes L dash and this R becomes R dash. Okay, this L dash and R dash, they are sorted version of this L and R. Then what we'll do, we will merge them and get a sorted array A. Okay, so let's write a procedure for this. Now let us suppose we have the array A. This is the starting part of the array. Let us denote it by Q. This is the end point. Let us denote it by R. We are going to write this merge sort procedure. So merge sort. It will take the array A, the starting index of the array and the last index of the array. We'll calculate a midpoint from which this left part of the array and right part of the array will be divided. So let us denote it by Q. So Q will be equal to P plus R by Q, and we will take the floor of it. Then we will call this merge sort on this array A from P to Q for this left part, and merge sort on this array A from Q plus 1 till the end of the array for that right part. After calling this procedure, we have to merge this sorted array. So we will call a procedure merge for A, P and the mid index Q and R. This process will be repeated till this P is less than R. Okay, till this starting index is less than this last index, we will repeat this process. Now let's see how this merge works. So now we are going to see how this merge procedure works. So this is your initial array. You are dividing this into two equal parts, L left array and right array. So you are calculating this q, which is equal to q is equal to p plus r by 2. The floor of p plus q or p plus r by 2. Okay. Now you have to copy this left array into another array. So let us take that the size of this left array will be this q minus p plus 1, and the size of the right array, it will be r minus q. Okay. Now let us take two auxiliary arrays. Let's take L from 1 to, the size will be of from 1 to n1, and R from 1 to n2 be two arrays. We have taken two arrays and we will copy the elements of this left array into this and the right array into this right array. Okay. So to copy the element, you are copying at L of I index the value of this array. Okay. So we have copied both the parts of the array. Now at the end of this left part of the array, we will put infinity. So at L of n1 plus 1, you are going to put infinity. So here infinity indicates a very large value, and at right of n2 plus 1, you are again going to put infinity. Just because when you are comparing these two arrays and you are putting it in a sorted order, so what if this whole array is exhausted? So you will get here infinity, write here infinity, so that you can copy the rest part of the right array. Similarly, if this right array gets exhausted, so this infinity will help you to copy the remaining values of this left array. So we are putting infinity here. Okay. Now we have put infinity at the end of the arrays. Now we are going to copy this array. So we will take reinitialize I is equal to 1 and j is equal to 1. Then we will sort this array for k is equal to p to r. K is another pointer which is going to handle this A array. This A array, I is for this left hand array and j is for this right hand side array. Okay, and k is the pointer to this A array. Now if suppose left hand side the value at this index is less than or equal to r of j, then at A of k you will copy L of I. The smaller value gets copied and the value of I is incremented. Else right hand side value will be greater, so you will copy at A of k, you will copy r of j, and the value of j is incremented. Okay, so this is the procedure to merge two sorted lists. They are independently sorted and we are going to merge these two lists into one. So this is how the merge procedure works. Now let's see how the merge sort works. Suppose this is your given array. Let's mark the values. The value of p is 1 and the value of r is 6. So p is less than r because 1 is less than 6, that is correct. So we will calculate q. What is the value of q? 1 plus 6 by 2. So it is 7 by 2 and the floor of 7 by 2 is 3. So we will call merge sort on this array A from P, that is 1 till Q, which is 3. And in the next step we will call merge sort from on array A from Q plus 1, that is 3 plus 1, that is 4 till R. r is 6, and then we will call merge on the array A from 1, 3 and this 6. Now again the value of P is 1 and it is R. On this array the value of P now becomes 1 and the value of R becomes 3. We will calculate Q. Q is 1 plus 3 by 2, that is 2. So on this we will call mergesort from the array A. For this the value of Q will be 2. On the array A from P, P is 1, from 1 to 2. Then again mergesort on this array A from Q plus 1, that is 3 to 3. And then we will call this merge routine on the array A from P. What is P? 1, 2 and 3. Now again on this the value of P is 1 and the value of R is 2. So 1 is less than 2. So we will call it, we will calculate Q, that is 1 plus 2 by 2, 3 by 2, the value of Q becomes 1. Then we will call mergesort on this array A from P to Q, and again mergesort on this array A from Q plus 1, from 2 to 2, and then again merge on this array A from 1, 1 and value of R is 2. So now at the end we are calling this mergesort on array A from 1 to 1. So this is only one element and we know that only one element is sorted, and again this is from 2 to 2. This is also one element and it is also sorted. Then we will call the merge routine to merge these two elements and store the result in it. Similarly, we will call all the mergesort routines and at the end this merge routine. So you are seeing that what you are doing is you are given an array, you keep on dividing the array by half every time. So you are dividing this array. You are dividing the array and reducing it to half of its previous size. Okay. Then at the end you are solving this problem independently. You are dividing till you find the solution of this problem. Okay. So and at the end you are merging the solutions. So this procedure is divide and conquer. Okay. So you are following divide and conquer technique to solve this mergesort. Now let's write the recurrence for it. See, initially you had a problem of size n. By calculating q, you divided that problem into size of n by 2 and n by 2 each. You further divided this problem into size of n by 4, n by 4. You basically halve this problem. Again this n by 4, n by 4. On the next level, what you will do? N by 8, n by 8. Till the point the size of the array becomes 1. Okay. Now you see on this step the total size of the problem is n. In the next step the total size of the problem n by 2 plus n by 2, that is n. Here also n by 4 plus n by 4 plus n by 4 plus n by 4, which is n. On the next level also n. On the last level also n. This is a binary tree and we know the height of a binary tree is log n raised to plus 1, and the cost to solve the problem on each level is n. So The solution to the merge sort will be theta of n log n, and the recurrence will be t of n is equal to, you are dividing the problem by half each time, and then you are merging the problem. To merge, the merge routine takes theta of n. By solving it using master theorem, you will get the solution to be theta of n log n. So till now we have seen how divide and conquer technique works, how merge sort works. The main procedure in merge sort is the merge routine. Now we will see another sorting technique based on divide and conquer, that is quick sort, in the next lecture. Thank you.